Hello and welcome to the Maths Department. My name is Kasia Rejzner and I'm the Director of Admissions in the Maths Department at the University of York. You might ask yourself, what does it mean to be a mathematician? What do mathematicians do for a living? Well, one thing that we do is obviously teaching, but apart from that we also do research, and research in mathematics means creating new mathematics. And that could mean many different things. In particular, it means creating new technologies. York is a part of Quantum Communications Hub. It's a big initiative that brings together universities, industrial partners, a lot of expertise to work on these new technologies for quantum communication, for communication of the future. All this, quantum mathematics, quantum technology, people coming together and developing these tools that will be useful in the future society. You will probably have opportunity to take modules, take courses from people who do research in quantum mathematics, in quantum information, to be able to learn these things firsthand and maybe become a part of this initiative. And who knows, maybe in the future you will write your own quantum programs on a quantum computer. But that's not everything. There are also other aspects of mathematical research, of how one creates new mathematics. And here I listed some of them that my colleagues in York and myself are working on. And surprisingly, even very pure research in mathematics, even things that, you would think they can never be applied to anything concrete. Well, guess what? Most of mathematics actually gets applied to something. So even if you're doing very pure, very abstract research, it might end up being applied to something very, very concrete. This happens. Here, I mentioned a few examples of things that my colleagues in York worked on and got applied to very interesting problems. And one of them is something that we are all now thinking about. We are all kind of worried about, which is the research on COVID-19. Very early into the pandemic, early in the first lockdown, a bunch of my colleagues got together and they wrote a paper where they used their analysis tools, their statistical methods to find out more about what's going on. So here is the paper. And I think this is very important to note that mathematics is one of the tools that we have to try to fight and prevent future pandemics. And it could be very crucial for our society, for all of us. So you can become a part of this. You can become a mathematician, make a difference. Another great thing about doing mathematical research is that it also helps us become better teachers. It also informs our teaching, and we try to bring the newest results, the cutting edge research into the classroom to you guys, so that you know what's going on, you're up to date, and you learn these new developments from the very experts in the subject. And we also author books. So here is a number of books co-authored by my colleagues in York. I also did write one. However, this is more postgraduate material. And anyway, if you come here, if you take modules in these subjects, it can happen that you could actually have that module with somebody who literally wrote the book. Here is how the course looks like. When you start your first year in York, there are two core subjects that you will be taking. One is calculus, the other is algebra. They are foundations of everything else, everything that comes later in mathematics. So it's really very important to get a good grasp of these subjects, to study them well, because this is fundamental for everything that comes next. There is also a module in reasoning and communication where you learn how to communicate mathematics, how to think like a mathematician, how to reason like a mathematician, and then present your findings, present your results to a wider audience. This is very important, not just for your degree, where you will have to do it in various ways at various occasions, but also in your future job when you become a working mathematician. These skills are very important. You learn them early on and then you hone them throughout your degree. So at the end, you finish the degree as a fully fledged, ready to go mathematician. Other things in the first year include tasters of various subjects in mathematics that you could specialize in later on. So there is introduction to probability and statistics. There is introduction to applied maths. there is introduction into pure maths in the form of the course in real analysis. This is the first pure mathematics course that you're taking. And then based on that, you can decide what you want to focus on later. One of the things that we find really important in the way we teach mathematics at York is small group teaching. We think that you learn mathematics really by doing it, by getting hands-on experience with it. So all courses have small group lessons, which are called tutorials or seminars, where you work in a group with a tutor who helps you through problems, who gives you assignments and feedback, and you can practice, discuss, ask questions, and just improve your mathematical skills by doing mathematics, by getting this hands-on experience. Here is a typical week of the autumn term in the first year. There are some lectures, there are some seminars, so small group teaching. There are also problem classes. This is something between a seminar and a lecture. So the lecturer is going through problems, explaining how to solve these problems, and then you can use these tools and apply them in seminars and try to do things on your own. There are also things that are organized by student societies and the student union. So, for example, there is a Coffee and Calculus, which is organized by the Math Society, where you can get some help in calculus from other students. And there are also Friday drop-in sessions. There are many other initiatives where students get involved, where you can get this extra support from other people who have gone through this before, so, they know how it is to be a first-year student. Okay, and after you have that behind you, then there is obviously a lot more to come. So in the second year, you choose what you want to specialize in. You choose 2 out of 3 streams, out of 3 subjects that you can study. These are pure applied and statistics, and then this works as a foundation for everything that follows in the 3rd and 4th year. So you can see there is a large variety of courses, of subjects you can study. In applied, there is mathematical physics, for example, mathematical biology. In statistics, there is data analysis, so big data, for example. This is a very up-and-coming subject. There is also mathematical finance, where you get to apply these statistical tools, also modeling tools, to actual financial markets. A lot to choose from. Here is the more comprehensive list, where you can see various courses that you can take in your 3rd and 4th years. There is a bunch of quantum courses, so quantum mechanics. There's also quantum field theory, quantum information, so a lot of quantum mathematics happening. There are also finance courses, mathematical finance. You can choose whatever you like, whatever interests you. There's surely going to be a module that touches upon it. And finally, to finish your degree, you get to write a small dissertation. You get to do a research project on a topic of your choice. And this is an occasion for you to focus on a subject in mathematics that you really find the most interesting, to do your own literature review, to do your own research, and then you summarize your findings in a report. So this is an extra training in mathematical writing, in those communication skills that are going to be important for you later on. And you also get to present your work to fellow students. So again, training, getting across these ideas in mathematics. Here is a list of all the final year project topics we have. I don't expect you to read it, just to give you an idea that we have so many different possibilities, so many different options. I'm sure that whatever interests you, you can find it there. Let me just mention a few. There is the time travel. This is one of my own. Random graphs, monstrous moonshine, a topic in pure mathematics, game theory, another one I supervise, non-commutative topology, another pure mathematics subject, many, many more. So whatever you really want to do, whatever you want to focus on and do a little research project on, you're going to find it there. This finishes my speed run through the degree in mathematics at York. I hope you enjoyed the presentation. Have a great day, and I hope to see you in York. Bye!